In previous videos, we have seen different types of basic Python constructs, which are variables, assignments, expressions, and conditional statements. What we need is what we call repetition statements. These statements are necessary to program more meaningful applications. I can say pretty much every application includes these repetition statements. A repetition statement is in Python called a while loop or a for loop. There are two different types of repetition statements. These statements are, as the name says, used to repeat other statements. So we want to tell the computer repeat a specific tasks. In order to understand these, let's get into three different applications through which we can understand the basics of loops. I'll just take very simple applications that may not seem to be very useful, but are useful enough to demonstrate the basic understanding of these loops. The first one, which is a more detailed one, is called the while loop. The second one is for loop. For loop is used with sequence types. While loop is not restricted to any specific type. Let's say we want to have a program that prints from 0 to 100. That would require us to write print 0 and then print 1, print 2, and then we can repeat this until we reach print 100, and that's it. So our program would continue with all these print statements so we can get the results. What if we wanted to print another range of numbers, say from some 50 to 2500? These will make it a bit more difficult to write the program as we are doing it now. How about we want to ask the user to input two numbers and then we print the range of values between these two numbers. So say we have a starting point, which is enter the first number. So this is called S, and then we have an endpoint, enter the second number, and then here we want to print out all the integers between S and E, including S and E. For these applications, we really need something different, and that is the while loop. What we could do is that we can start our loop with the word while, and then say while S is less than or equal to E. We want to do something. Excuse me, this has to be like that. So what we want to do is to print the value of S and then add 1 to the value of S. What am I doing here? I'm taking this starting point value, assuming that S is less than E, just for simplicity, and then putting a condition that would stop my repetition. So we want to repeat these two statements up to a point. And what is that point? That point is the value E. So we want to print S and then S plus 1 and then S plus 2 up to the value E. So we want to say that while S is less than or equal to E, we want to print S and then add 1 to it. So if we add 1 to it, what happens is that this statement, the whole statement, is repeated by the computer. So now we go ahead and check the new value of S, whether it is less than or equal to E, and then if that was true, we can continue with the values printed as they are. This is very similar to a conditional statement in which we have an if statement, a condition which guards the execution of whatever is inside that if statement. If that condition was true, we just go ahead and execute. If the condition was not true, we just neglect whatever is inside the conditional statement. With the while loop, that is true, plus the fact that the while loop will not stop once the last statement inside the while loop was executed, it will just move on with the condition here. The condition is checked again, and then we enter the loop if the condition is still true. So this condition has to depend on something that progresses towards it. So if there is no progress, this loop will never become false, and then we are into a problem. In this case, the condition can become false as far as we are stepping towards it. Let's test this program and see what happens. The starting value, let's say, is 9, and the end value is 10. So the program would just print 9 and 10. Now how about the starting value is 9 and the end value is 100? So as we can see, all these values between 9 and 100 are printed as we wanted. This is a simple application that uses the repetition statement, as we can see here. So instead of writing these values or these statements many times, we can just tell the computer that these need to be repeated up to a certain point, which is specified by this condition. So this is the first application. The second application would be, we can modify this program so that, say we want to print 10 numbers randomly. Say we have a lottery going on, we want to generate 10 different values that are between S and E. So these are integer values. The lower bound would be S, the upper bound would be E, and these are just randomly generated based on the uniform distribution. What we need to do is to import a library called the random library, and we want to also add another variable called the iterator variable. We call it I, and then what we want to do is that we want to control the number of times the while loop is repeated using this variable I. So we can say while I is less than 10, so this will make sure that when I reaches 9, the iterations will stop, and then we want to make sure that there is progress toward this last value here. So we want to add or increment I every iteration. We don't want a print S here, we want to generate a random value which is between S and E, and then print that random value. Okay, now we can test our application here. So the first value would be, let's say, 0, the last value would be 20, and now we can see that we get 20, or we get 10 different random variables which are at most 20 or at least 0. If we run this program with the same range again, we can get different values. It's not guaranteed to get different values, but most likely we'll get different values because these are uniformly drawn from a distribution. So this is another application of while loops. We could have a third application which involves a sequence variable. What we could do in this case, I'll just comment out this one because I want to get back to this again. We want to have a string, we call it S, so enter string, and another string, we call it T, enter the search character. The application here is that we want to search for a single character string here, which is T, in this probably bigger string S. So we want to see if this string S contains the character that is stored in T. Not the character T, but the character that is stored in T. So this requires that we write a while loop that inspects every character in S and checks whether that character equals the character in T. If that is the case, we want to print a message that we have found the character in S. Otherwise, we just want to say that this character is not in S. So what we can do here is that to have that iterator variable again. So this time I goes from 0 up to the last index and the variable s. So that would be I less than the length of s, because I will not put an equal sign here, because the last index in any sequence would be the length of that sequence minus 1. So this condition would do just fine. And we'll need to have that progress because we want to check every character in order. What we need to do is to have that if statement, if s of I equals the string t, print, we can say t found in s. So this is a way to format a string. We can just put these curly characters and write a variable name inside it and have that f, meaning formatted string, and then we'll just print the value inside t and s for us. Okay, so let's try this program here. Let's say hello and then the character L. What we see is that we have a message printed twice, which is L found in hello, L found in hello. Why is that? Because essentially the program is checking every character here. So checking H, is it equal to L? No, we'll just go ahead. Checking E, checking L, yes, the print statement is executed. Checking L again, the print statement is executed. So we have the print statement twice. But we certainly don't want that, because we just want to tell if L exists in hello or not. We just don't want to see how many times. That would be a different application. In this case, we want to do a modification here to tell the program stop the loop exactly when we find the first L, or the first occurrence of the character t in s. So the break statement would do just that. It will just break the loop at this point and get out of it, and would print or do whatever is outside the while loop. In this case, we don't have anything else, so the program terminates. Now let's see what happens with the new change. We can see that now the print is executed once. Now in this case, if we also want to get the reverse message, let's see. So if we had, this was the string, and then the second string was not found in the first string, we just don't get anything. That could be annoying to the user. We can add an else here to say t was not in s. So let's see what happens. Now we can see that the else would here work fine, because it's just similar to having an else for this if a statement, but I don't want to put it inside because I don't want this message to be repeated. Now once we have that break statement, this message would be repeated only once, and only when this print statement is not executed. Now this is the third application. We can see how the repetition is working for us, and it can work with dynamic values. In this case, the variable s could be any string of any length, as far as it just fits our memory. I can now move to the second type of the repetition statement, which is the for loop. The for loop would hide some of the details from the while loop. I can start converting this while loop to a for loop to just see what happens. For loops always work with a sequence variable. In this case, the sequence is s, and we are searching through it. So it's very easy to convert this one to a for loop. What we can say is that for character in s, as simple as that, I don't need to have that i+1 here, and then I can remove this and put this character c here. That's it. This is all the changes that I need. Of course, I don't need this variable anymore. What I am doing here is that I created a loop that would start with the first character of S and it would end with the last character of S. So there is no specific condition here. The condition is always the last element of the sequence. And there is always a progression towards the next element in the sequence. And what happens that if every time when the loop is iterating, every time when the loop iterates, we are getting a copy of the current element of this sequence here into this variable. So C always gets a fresh copy of the next element available in S. Okay, we can see how does this work. Exactly as we wanted. And then when the string doesn't exist, we just get the second message. So this is simply how the for loop works. This is the third application. We can move backward to the other applications. Let's take this one and change it to use a for loop. So the application here was that we were generating 10 numbers and printing them. So what would be the sequence that we are dealing with? The sequence would be these 10 iterations. So what I need to do is to use a different sequence type called the range type with a built-in function called range. I can say that I is a sequence of integers in this range. As we get here at the help from the editor, the range function could be used in different ways. We could just use the stop number, the last number of the integer sequence that we want to generate. In this case is 10. Of course, excluding 10. So these would be 0, 1, 2, up to 9. Or we could specify from 0 up to 10, not including 10, every time add 1. Could say every time add 2. In this case, we just want to add 1. So this will create a range of integer values from 0 to 9. I don't need this variable declaration here anymore. And then I don't need the I plus 1 here. The I plus 1 would just happen with this range function here. So that's it. Now we have another simplified for loop here. So the first number, let's say 1, and the last number would be 10, and these are 10 values between 1 and 10. Okay, now if we go backward to the starting application, which was printing all the values between S and E, what we need to do is put the starting value here, S and E, and the problem specified that we need to include E here, so we go up to E plus 1 because the last value here will not be included. And we can just remove that and put an I here. We don't need the random functions. So how about 1 to 10, and then we have that sequence for us. These are of course very simple applications of looping. There are many more different and complex types of loops. There are nested loops, that we have loops inside loops. There are many mathematical problems that could be solved with loops. There are many computer science programs that we can write with loops. For example, searching and sorting, and things can get very complicated. But this tutorial was just to get started with loops and see what we can basically do with loops.